Welcome to Introduction to Logic with Dr. Cecilea Mun. Today's topic is about identifying statements in an argument. Why do we identify the statements in an argument? Identifying the statements in an argument is the first step to analyzing an argument. The aim of analyzing an argument is to have a deep understanding of that argument, and the purpose of doing so is to ensure that one has a good understanding of that argument before they begin to evaluate, accept, or argue against it. When one has a deep understanding of an argument, they not only understand which statements make up the argument, but they also understand which of these statements are the premises and conclusions, as well as how specific premises and conclusions are related to each other in order to eventually support the main conclusion or conclusions of an argument. Analyzing an argument is especially important if we want to be a good decision maker, since making good decisions often involve making judgments about whether a certain argument is a good or bad argument, and we should always want to first ensure that we accurately understand an argument before we judge it. We can summarize what is entailed in analyzing an argument as the following 3 steps of analyzing an argument. First, identify all and only the statements that make up an argument. Second, identify which statements are premises and which statements are conclusions, including the main conclusion or conclusions. Third, determine the way in which the specific statements of an argument are related to each other, as premises and conclusions, in order to eventually support the main conclusion or conclusions. In this lesson, we'll focus on the first step of analyzing an argument, which is the step of identifying all and only the statements that make up an argument. Steps 2 and 3 will be covered in the next lesson. How do we identify the statements in an argument? To understand how to do so, first recall in the last lesson about statements that you were introduced to 2 different kinds of statements: categorical statements and propositional statements. Here are examples of each kind of categorical statement and propositional statement that we discussed. If you have yet to participate in that lesson, you should do so before continuing on with this lesson. You can find a link to it at the top right corner of the screen and in the description box below. The 4 types of categorical statements we discussed are: an A-type statement. For example, all humans are mammals. An E-type statement. For example, no humans are mammals. An I-type statement. For example, some humans are mammals. And an O-type. For example, some humans are not mammals. The 5 types of propositional statements we discussed are: a simple statement. For example, it is raining. A negation. For example, it is not raining. A conjunction. For example, it is raining and it is sunny. A disjunction. For example, it is raining or it is sunny. And a conditional statement. For example, if it is raining, then I will take my umbrella. These are all examples of categorical or propositional statements in standard form. In other words, each of these statements follow a specific pattern that all the statements of each kind can be put in. We can see the specific patterns for each kind of standard form categorical statement if we replace the particular category humans with a capital letter, H, to remind us that the letter H stands for the category humans, and we replace the category mammals with a capital letter, M, to remind us that M stands for the category mammals. The result is the following patterns for these specific examples of standard form categorical statements. For the A-type statement, the pattern is all HRM. For the E-type statement, the pattern is no HRM. For the I-type statement, the pattern is some HRM. And for the O-type statement, the pattern is some HR not M. We can also replace the capital statement variables H and M in these statement patterns with variables that stand for any category of things. We will use the lowercase, italicized letter S as the variable for the subject term of each statement and the lowercase, italicized letter P for the predicate term of each statement. The result would be the following general standard forms for each of these kinds of categorical statements. For an A-type statement, the general pattern is all SRP. For an E-type statement, the general pattern is no SRP. For an I-type, the general pattern is some SRP. And for an O-type statement, the general pattern is some S R not P. Unlike categorical statements, which are made up of categories of things, propositional statements are compositionally structured. In other words, unlike categorical statements, propositional statements are simple statements or composed of simple statements. So, the smallest unit of a propositional statement is a simple statement. And when we try to isolate the pattern of a propositional statement, we need to first determine the simple statement that is involved. Furthermore, once we identify the simple statement that is involved, we use a letter to represent this simple statement. The letter can be any letter of the alphabet, and we typically use the capitalized version to represent a particular statement. Finally, once we assign a specific capital letter to a particular simple statement, we do not assign that letter to any other statement, and always use that letter to represent that particular statement wherever that particular statement occurs. So, consider the following. Let us say we have the following three simple statements. It is raining, it is sunny, and I will take my umbrella. Because these are three different simple statements, we will assign each simple statement a different capital letter. We will use the capital letter R to stand for the simple statement it is raining, since the letter R will help us remember that the letter stands for the statement it is raining. We will use the capital letter S to stand for the simple statement it is sunny, since the letter S will help us remember that the letter stands for the statement it is sunny. And we will use the capital letter U to stand for the simple statement I will take my umbrella, since the letter U will help us remember that the letter stands for the statement I will take my umbrella. Given these three simple statements, the negation it is not raining can be presented by the statement pattern not R. The conjunction it is raining and it is sunny can be represented by the pattern R and S. The disjunction it is raining or it is sunny can be represented by the pattern R or S. The conditional statement if it is raining, then I will take my umbrella can be represented by the pattern if R, then U. Once we do so, we can see that each kind of statement can be associated with the following general pattern, where a lowercase, italicized letter can stand for any particular simple statement. The word or word phrase not, and, or, and, if, then, are called truth functional operators because, as you will learn later on when we discuss evaluating statements, they help determine the truth value of a propositional statement. For now, simply keep in mind that these truth functional operators are not a part of any simple statement, but instead help turn a simple statement into a larger, more complex statement, like a negation, conjunction, disjunction, or conditional, when they are used with one or more simple statement. So, although they are not a part of any simple statement, they are always a part of more complex statements. The result is the standard form for each of these kinds of propositional statements. For a negation, the general pattern is not S. For a conjunction, the general pattern is S and P. For a disjunction, the general pattern is S or P. For a conditional statement, the general pattern is if S, then P. Like the standard forms for categorical statements, these forms are not actual statements. They are instead patterns, like recipes, for creating actual statements that have the associated form. We can take these standard patterns and replace a statement variable with any kind of simple statement, and the result would be a statement of the kind for the form we used. We can translate many statements in ordinary language into a standard form categorical or propositional statement. Furthermore, doing so will help make analyzing and later evaluating statements and arguments a lot easier, since the specific patterns of standard form categorical and propositional statements will help us more easily identify the kind of statement we are working with, as well as how to apply other kinds of patterns, such as patterns with determining the truth value of a statement and patterns in the reasoning of an argument. But much of this will come later. For now, we will concentrate on using our knowledge of standard form categorical and propositional statements to help us identify the various statements that make up an argument. Since each kind of standard form categorical and propositional statement has a pattern that is associated with it, attending to the pattern should help us identify the various kinds of statements that make up an argument. In other words, these statement patterns should help us accurately bracket and number each statement in an argument, since what we are doing when we bracket and number statements in an argument is identifying all and only the statements that make up that argument. To accurately bracket the statements that make up an argument, you should see if you can identify all the statements that follow at least one of these statement patterns. Then, place an open bracket at the beginning of the statement and a closed bracket at the end, making sure that you enclose all the parts of the kind of statement that you believe you are bracketing inside the statement brackets. There are two things to notice about how both categorical statements and propositional statements are bracketed. First, statement brackets are always used in pairs. So, no statement has a statement bracket in the middle of a statement, and each open statement bracket has a corresponding closed statement bracket. Second, the brackets always contain a complete sentence. Statements are kinds of sentences. So, each pair of statement brackets should contain a full sentence. When bracketing categorical statements, notice how each kind of categorical statement is bracketed with an open bracket placed before the word all, no, or some, and a closed bracket at the end of whatever the category of things comes after the words are or are not. You should also always have at least two categories of things inside the statement bracket. One of the category of things will typically be placed after the words all, no, or some, while the other category of things will be placed after the words are or are not. When bracketing propositional statements, simple statements should be bracketed with the open bracket in front of the beginning of the statement, the closed bracket at the end of the statement, and there is no truth functional operator such as the word not, and, or the word phrase if, then inside the statement brackets. A negation should be bracketed with the open bracket at the front, the closed bracket at the end, and notice that what is inside the statement bracket is the truth functional operator not. All negations must have the truth functional operator not inside their statement brackets. A conjunction should be bracketed with the open bracket at the front, the closed bracket at the end, and notice that what is inside the statement bracket is the truth functional operator and. All conjunctions must have the truth functional operator and inside their statement brackets. However, with conjunctions and only with conjunctions, you can also instead split each part of a conjunction, which are called conjuncts, into separate statements. For example, consider the conjunction "it is raining" and "it is not sunny." Now, when bracketing a conjunction such as "it is raining" and "it is not sunny," although it is a single statement, which means we can bracket and number it as a single statement with the open bracket at the front and the closed bracket at the end, we can also split the conjunction into two separate statements, one statement for each conjunct. We can do so because doing so does not change the meaning of each statement. So, we can split the conjunction by bracketing and numbering each conjunct as its own statement without changing the meaning of each statement. This is because when we split a conjunction into its conjuncts, each separate conjunct, when asserted together at the same time, means the same thing as the conjunction. So, if I said at the same time the statement "it is raining" and the statement "it is not sunny," this would mean the same thing as me saying "it is raining" and "it is not sunny." Accordingly, from the single statement "it is raining" and "it is not sunny," we can have two separate statements, the statement "it is raining" and the statement "it is not sunny," without changing the meaning of any of the statements involved. Furthermore, note that there is no clear and fast rule to help us decide when to split a conjunction into its separate conjuncts when we analyze an argument. To this extent, analyzing an argument can be considered an art, and things will become easier with practice. In the beginning, however, as you start to learn to analyze arguments, it might be easier to split every conjunction into its conjuncts as separate statements every time you come across a conjunction. And I will do so throughout this and future lessons. Also note that conjunctions can have two or more conjuncts. More than two conjuncts are often introduced in a single conjunction with the use of commas and the word and. For example, consider the conjunction: "The pursuit of life, liberty, and happiness is every person's innate right." This conjunction has three conjuncts, and we can identify each conjunct by understanding that some of these commas, when used with the truth functional operator,
and,
stands for repetitive uses of the truth functional operator,
and.
So, the statement, "The pursuit of life, liberty, and happiness is every person's innate right," can be interpreted as the statement, "The pursuit of life and liberty and happiness is every person's innate right." Furthermore, some of the commas help to mark the beginning and or the end of some of the conjuncts. So, we can use some of these commas to help us understand where some of the conjuncts begin and end and split the conjunction accordingly. The result is the incomplete statement,
the pursuit of life,
the incomplete statement,
liberty,
and the inaccurate statement, happiness is every person's innate right. So, we now need to rewrite each statement to make sure we have 3 complete statements that accurately reflect the meaning of the larger, complex conjunction that they are a part of. When we do so, we have the following 3 complete statements. The pursuit of life is every person's innate right. The pursuit of liberty is every person's innate right. The pursuit of happiness is every person's innate right. We can also verify our result by making sure that the separate statements we ended up with, when asserted together, mean the same thing as asserting the more complex conjunction. In this case, we can ask if the 3 statements we have, when asserted at the same time, mean the same thing as the more complex conjunction. The pursuit of life and liberty and happiness is every person's innate right. The answer is yes, since the more complex conjunction is just a shorter way to assert the 3 separate statements. A disjunction, like a conjunction, is also made up of simple statements or negations as parts. But unlike a conjunction, you should always have the truth functional operator, or, inside the statement brackets when you bracket a disjunction. Also, you cannot split a disjunction into its separate parts, which are called disjuncts, when you bracket statements. This is because if you split a disjunction into its disjuncts as separate statements, this will change the meaning of these statements. So, if I split the disjunction, it is raining or it is sunny, into its 2 disjuncts, it is raining and it is sunny, the meaning of these 2 statements when spoken at the same time would be something different than the meaning of the single disjunction. When someone asserts this single disjunction, they are asserting that it is raining or it is sunny, whereas if they assert each disjunct as a separate statement, at the same time, they would be asserting that it is raining and it is sunny. So, unlike conjunctions, you should never split a disjunction into its separate disjuncts when analyzing an argument. A conditional, like conjunctions and disjunctions, are also made up of simple statements or negations. But unlike these propositional statements, conditional statements always have the truth functional operator, if, then, inside their statement brackets. The parts of a conditional statement, which is referred to as the antecedent and the consequent, should also never be split into their own statements. The reason is very similar to why you should never split a disjunction into its separate disjuncts. If you split a conditional statement, making the antecedent and the consequent their own statement, the meaning of the statements, when asserted at the same time, would not be the same as the single conditional statement. For example, if we take our conditional statement, if it is raining, then I will take my umbrella, and split it into 2 separate statements, it is raining, and I will take my umbrella, in accordance with its antecedent and consequent, the resulting 2 statements would mean something different when they are asserted at the same time compared to the statement, if it is raining, then I will take my umbrella. When someone asserts the conditional statement, if it is raining, then I will take my umbrella, they are saying that if the condition that it is raining is fulfilled,
then
the condition that I will take my umbrella will be fulfilled. Whereas when they assert the statement, it is raining, and the statement, I will take my umbrella, at the same time, they are asserting that both the condition that it is raining and that I will take my umbrella are fulfilled. Also note that you cannot split the 2 clauses of a conditional statement, the if clause and the main clause, into 2 separate statements because the result will be 2 incomplete statements. For example, if you did so with the conditional statement, if it is raining, then I will take my umbrella, the result would be the 2 incomplete statements. If it is raining, and then I will take my umbrella. So, like disjunctions, never split a conditional statement into its parts as 2 separate statements when identifying the statements of an argument. Finally, as we discussed in previous lessons, when bracketing and numbering statements, you always number your statements as you read them. Furthermore, 2 or more statements with the same meaning should be given the same number. However, you should make sure that all the statements to which you are assigning the same number actually have the same meaning. For example, consider the following 3 statements. I don't like ice cream. I do not have a preference for ice cream. I hate ice cream. The first statement, I don't like ice cream, has the same meaning as the second statement, I do not have a preference for ice cream, since to like something means the same thing as having a preference for something. So, we can bracket each of these statements and give both statements the same statement number, such as number 1. The third statement, I hate ice cream, does not mean the same thing as I don't like ice cream or I do not have a preference for ice cream. Although not liking something or not preferring something and hating something might be similar to the extent that all three involve desires and some kind of effect or emotion, not liking or not preferring something are both very different from hating something. When someone does not like something or does not have a preference for something, they might simply not choose it. But when someone hates something, they might try to actively get rid of it. So, we would bracket this third statement and give it a different number compared to the first two, such as number 2. Now that you know how to appropriately bracket and number statements, put what you learned to the test by completing the following practice assignment on your own. Then, join me for the next lesson, and we will go through the answers together. Toward the end of this lesson, I will give you a total of 6 arguments. Pause this video to write down the arguments or take a screenshot of them, then follow the following instructions. Also, note that these instructions contain a summary of the main points in this lesson. Instructions. Bracket and number each statement, as explained in this lesson by placing an open bracket at the beginning of each statement and a closed bracket at the end of each statement. No bracket should occur in the middle of any statement, and each open bracket should have a corresponding closed bracket. Each statement that is bracketed and numbered should be a complete sentence, and you should never split a categorical statement, simple statement, negation, disjunction, or conditional statement into 2 or more statements. You should also, at least for now, always split conjunctions by turning each conjunct of a conjunction into a separate complete statement and making sure to separately bracket and number each conjunct as a complete statement. If you need to remind yourself that each incomplete conjunct is a complete statement, you should rewrite any incomplete conjunct as a complete statement before bracketing and numbering it. When you number statements, always number each statement as you read them and give 2 or more statements that have the same meaning the same number rather than different numbers. Here are the 6 arguments for you to practice the first step of analyzing an argument. Pause this video to write down the arguments or take a screenshot of them, then follow the following instructions. Argument 1. If Socrates was human, then he was mortal. So, since Socrates was human, Socrates was mortal. Argument 2. All human beings are beings of equal intrinsic worth. Consequently, no human beings are beings that should be intrinsically valued above any other human being. Argument 3. Truth is crucial because without truth, individuals would be constantly misled and unable to make sound judgments based on reality, given that truth allows us to accurately understand the world around us. Argument 4. Insofar as the universe exists as a complex system, this implies that if the existence of such a complex system requires a creator capable of conceiving such a complex system, then God exists. It also follows that if all existing things must have a final cause and God is defined as the final cause of all things, then God exists. Argument 5. Considering that emotions are at times rational and at times irrational, we can conclude that emotions are not always irrational. We can also conclude that emotions are not always irrational in light of the fact that some of our most reasonable ethical decisions depend not on cold utilitarian calculations, but instead on the reasons of humility, empathy, love, and compassion. Argument 6. Cooperation is ultimately more beneficial for a society than cutthroat competition since cooperation leads to greater collective success and promotes social harmony. Cooperation leads to greater collective success because when people work together, they pool resources leading to better solutions and higher efficiency. Also, given that societies that emphasize cooperation tend to have less conflict, stronger relationships, and higher levels of trust, it follows that cooperation promotes social harmony. This brings this lesson to an end. I hope you learned a lot and am excited about applying what you learned in completing this practice assignment. And make sure to join me for the next lesson, in which we will go over the answers to those arguments together. Thank you for your attention and...
Hi, Kung Fu Logic Kitty here. Who knew there was so much to know about identifying statements? You might also try applying what you learned to everything you read. All this stuff really helps improve one's reading comprehension. In any case, I hope you had fun, and see you later.